welcome to RoboCoders Judgment Day! Spec-driven AI coding tools face-off. Good news, no face-off. Generally, this talk is 3 hours long. We're going to do it in 25 minutes. So it's going to look a little bit different. We really tried to fit it into 25 minutes. The shorter we got was an hour. So that's kind of a very far away from what we need to do.
The good thing is that the video that Baruch was talking about, 3 hours video, is actually available somewhere on the internet.
Yeah, we will show you where it is. We will show you where it is. All right, so we're going to talk about two tools today because we don't have a lot of time. Both of them are very spec-driven centric. The one is GitHub Spec Kit that is available for a couple of months by now, making very interesting progress in the domain of spec-driven development. And the other, which makes all the news yesterday and today, is Amazon Kiro.
So don't despair if you are not seeing your favorite tool right now. Like I said, look it up this video that we were doing, and you might find your tool. Today we're going to focus on these things because Kiro has an opinionated way to handle
spec-driven development.
And Spec Kit is something also opinionated, but seems to be kind of available across the IDs. You don't have to.
So basically, if you want to use Kiro spec-driven development, you use Kiro. If you want to use Spec Kit-driven development, you can use it in almost any ID or tool. But we'll talk about it. Yeah, okay, who we are. My name is Baruch Sadogursky. I'm a head of developer relations at Tessl. We do awesome t-shirts. By the way, it's Wednesday, my dudes, if you didn't notice. Literally, it's Wednesday. And if you want to get awesome t-shirts, we have them to share the love around for good questions, comments, naming potatoes 3 times, and a bunch of other fun activities. AJ Baruch on the internet. This is my dear friend and partner in shenanigans, Viktor Gamov, principal developer advocate of Fluent. If you ever heard about Kafka, you probably heard it from Viktor. If you didn't hear about Kafka from Viktor, you should.
Yes.
Yes.
Wrote a book about Kafka, but not going to talk about Kafka today.
Not Kafka today. Edgar Musa all over the internet. So hit him up. He's awesome. Java in AI space. Interesting choice. One of the reasons why we're going to say some of the nasty things about the state of AI that we're going to say is because of our Java background. Basically, we think that state of AI now is a pile of smoking
markdown files.
Yes.
Pile of smoking markdown files.
Yes, exactly, which is terrible. It shouldn't be that way because we are Java developers. And OK. You go to shownotes.taxcare.com. In a couple of hours, you will see there a page dedicated for this talk.
Yes.
That it's going to have also AIassistedengineering.com. It will have the slides. It will have the video that we're recording right now. It will have all the links to everything that we're going to talk about. And it will have a raffle to say thank you for being here. There is a QR code. This QR code actually takes you to a previous version of this talk, which is like 3 hours. And expect a new version of this talk in the same space later today. All right. So as you know, spec-driven development is all the rage. Everybody is speaking about it. Only today, in this conference, there are at least 3 talks about Kiro, for example. And this is one of them. There was a workshop yesterday, and there is tons of content about it, and this is very hot.
There was no previous agreement about this, so that we're going to take this tool, or they will going to take this tool and talk about it. It's just awesome. That's why the good people pick it up and start using it.
What is spec-driven development?
What is spec-driven development?
Yes.
It's a process where you have a few steps. One step is that you need to define the requirements. So your application, you becoming more as a product manager. And as requirements needs to be good. If you have bad requirements, we have a slide for that about bad requirements. After we define requirements, we need to go to define a plan. How we're going to be solving those requirements. And usually it involves some of the design decisions, how the components will work.
For example, if you make a beef stew, one of the steps will be boil your potatoes.
Boil your potatoes.
That would be one of the steps.
Second, and the third thing is that we can break down this into particular tasks that will be used as an implementation. So a little bit of waterfall-y kind of like a style of doing.
And the tasks, as opposite two steps, will be with the potatoes, will be wash the potatoes and then put them in water and yeah, exactly. Yep. And then after we did the tasks,
we have an autonomous ability to implement those tasks.
The next step will be let the AI implement those tasks, right? So that's in a nutshell what those tools do. Kiro and Spec-Kit do it a little bit differently. You will see the difference soon, but that's kind of the big thing, right? So what do we have in store? Basically, this process formalized to different degree in both of those tools.
How are we gonna validate that what we get in right things? Kind of like one of the things would be, the code reviews, right? So we have our requirements described. We have the tasks specified. The tasks are linked to our requirements. So good, right? So we can take the code.
So this is a very good question, right? In the end of the day, we did all this process and we ended up with code that does something. How do we know that this code actually does what we want it to do? I mean, last we looked at the steps,
yeah.
And the steps looks great. Mm-hmm. Next thing we know, we have code running. How do we know? What do you do?
What would you do?
What do you do? It's not a rhetorical question. How do you know? Review the code. Thank you very much. Now there is one thing that developers hate, and that's reading someone else's code.
Yes.
And that includes your code from 6 months ago.
So what about, so we're doing this like an AI thingy. What about if the AI will validate our code?
Wait a second. I have more jokes about reading your own code.
Okay.
More jokes. Right. So why do we actually, but right, so we said like we hate reading other people's code, but code reviews actually exist and work, right, to some extent. Now why? Why are they work? Because mostly professional courtesy. You have a colleague that wrote some code, like Viktor wrote some code, he made a pull request. I don't have time for that. I'm in a completely different context. I secretly hate this guy for doing that. But I'm going to review the pull request because he's my colleague. I need to eat lunch with him tomorrow, and I'd better do it. You know what my code review will be? Looks good to me.
Yeah, ship it. LGTM.
Right?
Ship it.
Right. Now, so generally code reviews are not good. Now, remove the human that you respect from the loop. What are the chances that someone is going to do a proper review of the code that AI wrote? Not much. But Viktor had an idea.
Yes. So we're doing AI. It's like smart enough.
Yes. So
How about we're gonna ask AI to validate it?
Oh, there was something like, there was some way to validate that code does what we want. Anyone has any ideas? Something that starts with T. Tests, maybe?
That's the test.
Tests. Huh. That's a great idea.
It's a T-shirt.
It's a T-shirt, definitely.
Yes.
Whoever came up,
for discard after this.
whoever came up with this test thing deserves a T-shirt. This is great.
Absolutely.
Now, what is who's going to write the test?
AI?
AI is going to write the test.
Reviving.
Right? Now, so basically we have AI writing tests for the code that AI wrote. What can possibly go wrong?
AI rates itself and saying it's incredible.
It's perfect.
That's absolutely right.
Right? So, I mean, humans will write tests based on specification and won't adjust them to the bugs in code. AI is definitely going to do that. Circular verification is terrible. And if you ask AI to write tests for their code, they're going to play with both of them until it all passes, even if it doesn't make any sense. Don't do what you need, not related to the specs that you asked, and very, very far away from everything that you wanted to do. And that's because, not because AI is evil, although there's some research that it is, it's because AI is just a bunch of stupid monkeys. You know the saying, if you take infinite amount of monkeys, give them infinite amount of typewriters, and give them infinite amount of time, in the end of the day, they will write Shakespeare. Now, our AI models is exactly the same. It's a bunch of monkeys with GPUs instead of typewriters, and they are skewed towards presenting the right answer a little bit better than randomness. But in the end of the day, the scholastic nature of the AI systems and the non-deterministic nature of AI systems guarantees that the results will be a little bit different every time. Something will be Shakespeare, something will be Shakespeare-ish, something will be very far removed from Shakespeare. So what we definitely don't want to do, is trust the monkeys in anything remotely related to our production systems.
Yeah.
So saying that AI can actually verify our AI is a very bad idea.
Yeah.
What do we do instead?
So we need to come up with formal ways of verification. It turns out, we might have to step in at some point and interfere.
And we present you
intent integrity chain. That's kind of like a step up with the on top of the spec-driven development that will include certain interesting steps.
Now, it's not very different. We start with the same idea. We need to formalize the requirements. Then we review the requirements with humans, human eyes, because requirements are text, and agree that everything is good. Next step, we let the machine create specs. Again, very similar to what the spec-driven development does today, and we review the specs because the specs are human readable.
So every step.
Important stuff.
Okay.
Important stuff. Wait a second. Yeah. Okay, ready?
It's video or audio?
It's both. Okay, now it's video. The previous one was stills. All right.
It's going to explode my Instagram network after that. Yeah. So every step will require human interaction. So this step needs to be validated by humans, saying that yes, it's all good, it's all right. So let's go.
And here is where interesting stuff happens. Spec, as you will hear from our colleagues about Kiro, has a very particular type of text. They are not only human readable, they're also machine parsable. And the fact that they are machine parsable, the given when then structure, allows tests to be automatically, deterministically, algorithmically, 3 amazing words in one sentence.
Yes, it's like 3 potatoes that you're supposed to be saying.
I already did the potatoes.
You already covered,
yeah,
okay.
I covered the potatoes.
So +1, like extra potato.
Automatically, deterministically, and algorithmically generated from the specs. No monkeys involved.
Yeah.
Isn't it amazing?
It's amazing. And in this case, it is something that we can trust. And again, we can, if we don't like those, we can throw it away. It's tests.
After the tests are generated, we know for sure that tests match the spec, right? We know for sure that spec match the requirements. And call my bullshit if you don't agree with me that we know it for sure. And once we have the tests nailed down, we can ask the monkeys to write code until our tests are passing. Yes?
Are you referring to only technical specs or also functional and non-functional specs?
It's a very good question. The area of how do we write the specs so they will cover functional, non-functional, and any other types of requirements in the same format of given when then, it's an open question. You probably can cover more than 90%. Even load requirements, even security requirements, all can be formulated in given when then structure. There are probably some requirements that couldn't. And can we come with a better way of speccing? Probably. At the moment, this is what we have. All right, so this looks good. Let's repeat it now with colored arrows, because this is what we do. Okay, so software definition documents are prompt. LLM create the specs. Everybody read the specs and approve and agree that the specs represent the requirements. Algorithm generate the tests, no monkeys involved. Monkeys implement the read-only test until they pass. Beautiful? Beautiful.
Yeah.
There is another problem.
Here's another problem. Like, we do have a tools that designed around certain ideas. So we would talk about like spec-driven development and stuff, right? So we need to bridge this gap because those tools don't know this.
I have like, wait a second, I have like,
Better segue?
Yes, I have
Okay.
better segue, exactly.
Who knows what is that?
What's that?
Any Back to the Future fans?
If you're old enough to remember Back to the Future movies, this is Mr. Fusion. Mr. Fusion is an amazing engine
Yes.
that converts what? Garbage into
Energy.
energy. What we have with AI, and that's my best joke of the day, I promise you, is inverse Mr. Fusion. We put in a lot of energy and get
Garbage.
garbage. Huh?
Yeah,
Huh?
exactly.
Right?
Yeah,
Exactly.
landed perfectly.
Now, I bet you all can relate, right? For sure. One of the reasons is where our LLMs get the knowledge.
How many of you know what's the P stands in GPT? No one?
Pre-train.
Pre-train. What
Pre-train.
does it mean?
But you don't have to train it for each individual use case.
It means
Yes.
that the training is over.
Training already happened
Because it's
the
pre.
moment you already started. It's pre-trained. And the problem with that, this usually signifies certain like cutoff date. So the certain date in our reality that corresponds to all the events that happened like before this date.
Okay.
Meaning that it doesn't know about Java 25 maybe because the model was trained before release of Java 25. Or new version of Spring Boot
4.
or put your own framework in it.
Closed source that AI never heard about.
Especially enterprise repositories that have your corporate code that would be,
We need to speed up.
Yeah.
Okay, right. So pre-trained model knowledge is nice, but not enough. One of the reasons of inverse fusion. General web search, our modern tools can search web and give you results. It's nice, but probably not good enough because there is tons of garbage out there, incorrect information, answers on Stack Overflow, and other improper sources to look at. What about we teach our AI to read the manual? Make AI read the manual. How about this?
Yeah.
How do we do it? There are a couple of ways. First is Viktor.
First, we think that we're using the how it's called, the server that already pre-cached or indexed some of the documentation around the world. So Context 7 is a great service that exposes some of the information to LLM through MCP server. It's the topic for another talk, but essentially think about this. LLM will be able to speak and find any information about any library in the internet. Super useful tool, incredibly simple and just works.
Two downsides of Context 7. First, only public knowledge. Only public APIs, only public libraries.
Yes.
You won't put your closed source libraries to Context 7 to serve the entire internet. And the second is only latest version.
Yep.
If now you are stuck on older version of software that may be not supported anymore or end of life, first of all, you need tax care services, so talk to me. And second, you won't find the documentation in Context 7. What you can do then is Tessl. Thank you, Tessl, for hosting us in this conference. So Tessl, think about it as your both external public source of knowledge for AI, but also cached private in-house source of knowledge for AI. You can put there your closed source libraries. You can put there not the latest version. You can use Spring Boot 2. You can use Spring Framework 4. You can use Java 8 documentation for there. And then your AI will know all that and will know it perfectly. All right. So you ready to fix spec-driven development?
Yes.
Let's do
let's
it.
Let's
we
fix,
have 6 minutes.
6 minutes. It's a probably perfect time to fix spec-driven development. First of all, we have a Kiro here. The one I personally like about this, it has a very nicely integrated UI components that will, since we're working on this particular feature, is application that needs to communicate through REST interface with the bulb and light the bulb with the color light that this application will read from webcam. Don't think about this right now. Find the video on the internet. It's actually pretty fun. We hanging around. Reason why we bring this bulb, because it's some sort of like obscure library that LLM probably don't know how to use. However, we can use all the tools that we described. So first thing is that the Kiro has support for Context 7. we need to explicitly tell it how to do this. And one of the ways how you can do this in Agentic IDEs is using things called steering or guide rails. Different IDEs call it differently. For example, this steering, which says there's a critical rule. Before writing any code, you must always consult MCP, Context7 MCP for library-specific APIs, patterns, and best practices. So every time when it will try to code, it needs to follow this rule. You see? Because it's all capital, all caps, so meaning that it's important thing that the model needs to take seriously.
Very important.
So
Caps.
we have now we have the spec-driven development here. So we have requirements, we have design that was generated. See, even like some ASCII art for generating
Solid design.
Solid, but broken. But anyway, so there's specification, has like different methods what to invoke. So basically we have it. And most importantly, we have a task list. What we don't have?
We don't have tests.
Yeah, we don't have this generated test thingy.
Terrible,
So
terrible.
for that matter, we do have the concept of the agent hooks where we can put these some generic prompts. And in this particular case, prompt will say something like this. Let's go hooks. Put it here, and essentially what it says, read requirements, read design, and now create test files following TDD principles. That should be blah, blah, blah executable, covered all the stories in requirements, a proper testing framework based on technical stack. So it will, we can say specific framework, but in this particular case, we're saying, like, choose whatever. Want to do JUnit, go for it. If you want to do test in G, it's up to you. So,
and what is the hook for this?
Oh, the most importantly, that every time when we will be updating tasks, this is like the task file that will include our tasks, we will run this hook. So I will go and create this hook and show you how this would work in this integrated UI. So I'm going in to say like my task list. We'll give it a moment because the conference Wi-Fi and we're in the basement. So hopefully it will. Okay, hook was created and it will automatically trigger whenever we should say not created by saved. That's one of the things that. So if I will run this task, in this particular case, set up the project structure, so I'm expecting this will go and generate some tests for me. So task in progress, so it will go ahead, create the Maven dependencies, Spring Boot, blah, blah, blah. And we automatically see in here that auto-generate TDD tests, and it would be queued, meaning that there is a task in queue that will be executed here. And after that, we're going to invoke those things back to. All right. And yep.
All right, test kit. I have test kit running with GitHub Copilot in Visual Studio Code. Test kit can run in tons of different models, AI tools, Claude Code, like really everything that you can think about in any editor, Cursor, Windsurf, etc., etc. And this, what you see here, are the suggested actions.
Presentation mode.
Oh, thank you. Where is it? Where is it? Where is it? I need to do, sorry, I need to do this, and now I need to do this. Come on, where is my, okay, here we go. Sorry about that. Yeah, so those are the commands that I can run as spec kit commands that will do all the steps of our spec generation. And you can see here constitution, and that's the steering, whatever steering is called in Kiro. That's like the golden rules, write clean code, or like this kind of stuff. And then specify, we describe what we want to build, it will create a spec. And then plan, this is the technical specification. We're going to use Java 25 and Spring Boot 4, etc., etc. Tasks, we'll break it to the smallest tasks possible, like wash your potatoes, and then implement. Again, no code. There is no test. There is no step for creating test, which is, as we spoke, not great. So what we're going to do, and this is one of the things that both fascinate and terrify me, is we're going to add 2 Markdown files that will completely change how spec kit works. It blows my mind. All our industry now, AI industry, is all based on a bunch of Markdown files. It's terrifying.
Yeah.
right?
Speaking about pile of the
smoldering,
smoldering
right.
Markdown files.
So we're going to add an agent, new file. We're going to add an agent, which is called testify. Testify will be our new step. And this is a definition of a real agent in Copilot. So what we're going to write here is what this agent does. And what we say here is, like, you are an agent and responsible for test construction. This agent is going to generate the tests. And then we're going to add another file to the prompts. And this will add this new step that we spoke about. So this is, that's definitely not the right name file. Where is my rename?
F6?
Yeah, probably. Where is it? This, yes. And this is going to add this extra step. And this is actually also a file which is a prompt, right? So this is actually what the prompt will be that will be generated automatically for us to this agent. Once I added those two files, now suddenly I have here specify, testify, where is my testify? Yeah, no, did something wrong. But we're out of time. So if I edit it correctly, I would have here an absolutely new prompt that will generate the tests with the new agent that is in charge of writing the test correctly, and I can add as much information to this agent as I want of how do I think that I need those tests to be. Mm-hmm. And then I can also add a shell script that will run in the beginning of the implementation phase, making those tests read-only. And if I do that, I will prevent AI from messing with those tests, making them the source of truth for the implementation. One more thing that I wanted to add, and that's correct for Kiro as well, is our ability to switch models between the tasks. You probably don't think about it, you just run it with one model that you like. But if you do that, you benefit from two things. First, there are better models for different things. Thinking about spec, you might use a more heavily reason-skewed model, maybe ChatGPT 5.1. When you run tests and generate implementation, you might want a coding model. For example, Sonnet 4.5 or GPT Codex or any other one.
Can I say something in defense of this, like a pile of markdown smoldering files?
You have -3 minutes.
Yeah, so we talk about this a lot, but I think it also gives us some benefits, like a portability of the things, so we can move between different ideas since we're using the same information and it's going to be our source of truth for doing the things, right?
I'm Baruch. This is Gamusa. This is AI Native DevCon. Use this hashtag when you are raving about this amazing talk. Also use Intent Integrity check, the chain hashtag, and shownotes.tasker.com in a couple of hours. AI System Engineering in a couple of hours.
All the videos already there, and, like 6 hours, 3 hours video is there.
Yeah, 3 hours video, an hour video, whatever you like. Now it will also be 25 minutes. Thank you very much. We're out of here.
Yep.
Thank you. And